In this question, they're asking us to find the equation of a tangent line to the function y equals x plus 1 e to the negative 2x at the point x equals 1. So the first thing that we want to do is we want to find out what point is actually on our curve. Where are we actually taking this tangent line at? Now, they say at x equals 1, but it would be good to know what y would be in that case. So what is the actual point that we're looking for? Well, when x equals 1, that means that when we plug it in, we have y equals 1 plus 1 e to the negative 2 times 1, which, when you simplify, ends up being 2 e to the negative 2. So we would like to take our tangent line when x equals 1, and y equals 2 e to the negative 2. This is where we want the tangent line. So tangent line at this point here. Okay, so usually a good idea when trying to figure out the equation of the tangent line is to figure out the slope of the tangent line. And we know that the slope of a tangent line at a point is the derivative. So we're going to take the derivative of our function with respect to x. So dy by dx is equal to, well, we have a function here which is a product of two functions. It's the function x plus 1 times the function e to the negative 2x. So we're going to use the product rule here. So let's leave the first function alone and take the derivative of the second. The derivative of the second, using the chain rule, is negative 2 e to the negative 2x. And then we leave the second function alone, e to the negative 2x, and then take the derivative of the first function with respect to x. The derivative of the first function with respect to x is just 1. So now this becomes negative 2x plus 1 e to the negative 2x plus e to the negative 2x. At x equals 1, this means our derivative is equal to, plug in negative 1 into here, plug into 1, we get negative 4 e to the negative 2, because the x is now 1, so negative 2 times 1 is negative 2, plus e to the negative 2 times 1 again is just e to the negative 2, and if we simplify that, we end up with negative 3 e to the negative 2. So that is the slope of the tangent line at the point 1, 2 e to the negative 2. So this is our slope m. We have a point here, so now we have all the bits that we need to make up the equation of a line. So we're just going to kind of write down the skeleton of any equation of a line, y equals mx plus b. We know that when x equals 1, y should equal 2 e to the negative 2. We know what m is, so we use all these three pieces of information to figure what b is. So when, first of all, we're going to let our m be negative 3 e to the negative 2. When x equals 1, so we're going to put in x equals 1. When x equals 1, what does y equal? Well, we calculated that already. When x equals 1, y equals 2 e to the negative 2. And then we still have our b. So this allows us to figure out what b is equal to. If I simplify this, this becomes negative 3 e to the negative 2. And when I move this over to the other side to isolate for b, I end up with 5 e to the negative 2 equals b. So this becomes our b value. So now that we have a b value and an m value, we can now go ahead and write down the actual equation of the line, which is y equals, what is our m? Our m is negative 3 e to the negative 2. Y equals m x plus, and what is our b? 5 e to the negative